Hi Trojans, Mrs. Ratsburg here. We are going to continue with talking about similarity, but today we are also going to add in something called a scale factor. We are officially going to be defining that in our next lesson, but we are going to just start talking about it today. So let's just first review what we talked about yesterday. So to determine if the two shapes are similar, you're going to use the following checklist. Is it the same shape? And we like to just remind that with an S. Are the corresponding angle measurements equal? We like to remind that as an A. And then finally, are the corresponding side lengths proportional? And we like to say that as an S. And that gives us this abbreviation SAS, which happens to also be our abbreviation for this unit, stretching and shrinking. So this is kind of like our checklist as we go through and figure out, are these shapes similar? But now we're going to be adding an extra step, and we are going to be adding a step of if things are similar, then what in the world is the scale factor? And the scale factor is the number that the side lengths of one figure can be multiplied by to give the corresponding side lengths of the other figure. So down here below, the rectangles below are similar. The scale factor from the smaller rectangle to the larger rectangle is 3. So we see this right here, this times 3. And the reason it's 3, if we take this 2, the corresponding side length is this 6 centimeters. And how do you get from 2 to 6? Well, it's times 3, so that's the scale factor. And it would be true then for any side length, corresponding side length with these two figures. So 3 times what gives us 9, and that's 3. So our scale factors are consistent, which means it is indeed similar. But now it's asking us, what is the scale factor from the larger rectangle, so the 6 by 9 rectangle, to the smaller rectangle? So now we have to think, well, 9 times what number gets us 3? Well, I know I could divide. 9 divided by 3 is 3. But it says it has to be multiplied by something. So, oh, you know, when you divide by 3, that's the same thing as multiplying by 1/3. So divided by 3 is the same as multiplying by 1/3. So the scale factor would be 1/3. So it's just important, that is just showing that the order, that the direction that you're finding the scale factor is important, because we now have two different scale factors with these similar figures. One is 3, the other is 1/3. Okay, so I'm going to model questions parts A and B here, and then you're going to do the next two on the next page, page 9. Okay, so determine if the following are similar. If they are similar, determine the scale factor. So I always like to start off with my SAS checklist here, all right? And so what we'll do, we need to first think, well, are my shapes the same size? Or are they similar? Let's go back up to the checklist. Are they the same shape? Well, they're both rectangles, so I'm going to go with yes here. So I'm just going to give a check out. Next, A. Are our angles, our corresponding angles, equal? Well, they certainly look like it because I see all these right angle symbols, and so that means they're all 90 degrees, so I'm going to check it off. Third, this is usually the one that we have to work with the most. Are our corresponding side lengths proportional? So what we'll have to do, I like to use two different colors here, so I'm going to use green for one side length and corresponding side length, so 18. And the corresponding side length would be 30, right, both on top. And then my other corresponding side lengths, I'm going to do are 24 and 40. And so then I'm going to go ahead and write those proportions. So 18 over 30 equals, and then I have to go in the same order. So because I did the smaller rectangle first, I'm going to have to write my proportion, my ratio, with the smaller number on top again. So 24 over 40. And now I need to figure out, Well, is 18 over 30 equivalent to 24 over 40? And what I noticed with 24 and 40, I can divide both of these by 8 to simplify. And that gets me 3 over 5. And then on my green, I can simplify both of these by, divide them both by 6. 18 divided by 6 is 3. 30 divided by 6 is 5. Hey, look at that. 3 over 5. 3/5. So that means it is similar. Okay, so now they are similar. So I'm going to write similar. So now that we know that they are similar, now we have to actually identify that scale factor. So what we'll do here, I'm just going to change colors to show that we're in a different setting. We need to think, well, where do we want to go? Do we want to go from smaller rectangle to larger rectangle? And let's go ahead and do that this time. So I'm going to say, it doesn't matter which corresponding side lengths I pick, I just have to be consistent. So I'm going to think, well, how do I get from 18 to 30? And I know a scale factor has to be multiplied, so 18 times what number is going to get me 30? I don't really know that, but what I'm noticing is this 18 times question mark equals 30 looks an awful lot like an equation, right? I could write 18, instead of a question mark, I could write 18x equals 30. Then I could divide both sides by 18. 18 divided by 18 is 1, so I'm up with x equals. And then 30 over 18 is the same as 5 over 3. And so that's my scale factor, and I'm just going to label that small to big, or small to large scale factor. Okay, so now part B. So same process, we have to identify two sets of corresponding side lengths. So let me get my highlighter back out. I'm going to make my highlighter a little skinnier. Okay, so I'm going to do the top of my, let me first write SAS. Side shape, they look like trapezoids to me. Angles, it's hard to tell, so I'm just going to kind of put a question mark there for now, and if we need to address it later, well, we probably won't be able to because we're not given any numbers. And then side lengths, that's what we're figuring out. So now it's time to highlight some corresponding side lengths. So my 20 is at the top of my trapezoid, and so is my 22. And then let's go orange today. And then let's do the bottom of my trapezoid too. So 30 and then 36. So then what do I have to do now to see if my side lengths are proportional? Oh yeah, I have to make them into a proportion. So 20 over 22, so my blues first, equals, now my orange numbers, 30 over 36. Now before I even start simplifying, I'm noticing that 20 over 22 is really close to one whole, and 30 over 36 is not as close. So I'm going to go with they're probably not equivalent, but we'll find out. So 30 over 36, I can divide them both by 6. And so I get 5 over 6. And then 20 and 22, I can divide them both by 2. And I get 10 over 11. Well, golly gee. Those are not equal. They're not equivalent. So these two shapes are not similar. And because they're not similar, I would not be able to find a scale factor to go from one side length to the one shape to the next in terms of side lengths. So mine done. So now if we go down to the next two pictures, C and D, they're all rectangles. But notice how in D, the side lengths are not proportional. So that's going to be are not in the same orientation, excuse me. And what that means is notice how on this top one, the shorter side length is on the bottom, but in the bottom rectangle, the shorter side length is on the side. So I just helped you out there by finding one of our corresponding side lengths. So go ahead and pause me and find the corresponding side lengths for C and D. Okay, so we're back. So hopefully what you found in C was that they were not similar. You simplified those ratios and they were not the same. And then for part D, you hopefully found that they were similar and that your scale factor from small to big was 6. Because 5 times 6 is 30, 7 times 6 is 42. Okay, moving right along. So now we are looking at a lot of, well, they're actually mouths from the Wump family. And we need to figure out which pairs of rectangles are similar and show how you know with your checklist. So now we have a lot of different rectangles that we have to figure out. So let's think about this for a moment. So it looks like we're going to have to use our checklist, SAS. And I want you to pause and try and work through which of these rectangles are similar with each other. And I'm going to give you a hint because I'm that kind of a person. There should be 3 rectangles that are similar altogether. Okay, so go ahead and pause and figure out what they are. Okay, so hopefully what you found were that J, L, and N are all similar. So J, L, and N. So let's go ahead and go on to the next page. So now it says for each pair of similar rectangles, find that scale factor, the perimeter, and the area of each rectangle. So I just want us first down here, so our tables match. I want us to fill those out now. So that'd be L, J, and N. And then I want us to practice with our scale factors. So I'm going to be really specific, so go ahead and follow this too. I want you to find the scale factor from L to J. Then again, J to L, L to N, then N to L, then J to N, and N to J. And you're going to find, well, what number do I multiply L, the side lengths of L by to get to J? What number do I have to multiply from J side lengths to get to L side lengths? And these are all corresponding. So go ahead and try and work through that now, and then unpause and keep going. Okay, so hopefully you found all those scale factors. I forgot to mention to have you also find the perimeter and area, so go ahead, pause, and do that now. Okay, so you hopefully found the perimeters and areas of all those, so I'm just going to fill those in quickly. And then I do want to go over the scale factors. So from L to J, you should have found that the scale factor was 2. Because if you look at the pictures, so from L to J, L, one of our side lengths was 1, and J, a side length was 2, so 1 times 2 is 2. And then from J to L, well, that's just the opposite, and so that's going to be what's called the reciprocal, or 1/2, because 2 times 1/2 is 1. Next, we have L to N, and you should have, well, let's see. From L to N, well, that would be 3, right? Because 1 times 3 is 3. And then the opposite way would be that reciprocal, the flip. So 1/3. And then this is the hardest one, J to N. So from 2 to 3, how do I get there? So let's kind of do that math. So 2 times what number gets me 3? And we can do that by dividing both sides by that coefficient of x. So divide both sides by 2, and I get x equals 3/2 or 1.5. I like to keep them as fractions though, personally. So that would be 3/2. And then what we just have realized is that the other direction is the reciprocal. So the other, from N to J, the scale factor would be 2/3. Now, did you notice that the scale factors, if they were smaller than 1, the shape got smaller? Doesn't that make sense? When you multiply by anything that's less than 1, you get something smaller than that other number. Pretty cool, huh? Okay, so describe the relationship between the perimeters of 2 rectangles and that you pick and the scale factor. And then you also want to describe the relationship between the areas of two similar rectangles, the same as in 3, and the scale factor. So to be consistent, let's look at the relationship between L and J. So go ahead and pause and look at that relationship between L and J's perimeters, and again of L and J's areas. So go ahead and pause right now and answer those. Okay, so we're back. So we have a perimeter of 10 and a perimeter of 20. So that's L, that's J. What do you notice? How do we get from 10 to 20? Well, we multiply by 2. That's the same scale factor. So the change in perimeter is the scale factor. Okay, so then back to now area. So L, our area was 4, and J, our area was 16. Well, what's that? How do we get from 4 to 16? That's right, we have to multiply by 4. So 4 times 4 is 16. But where does that how does that 4 connect with our scale factor of 2? We said our scale factor was 2. 2 times 2 is 4. So the change in area is your scale factor times your scale factor. Or if you remember your exponent rules, that's the same thing as scale factor squared. Pretty neat. Okay, so finally, how can you decide whether or not two shapes are similar? So we had 3 things, right? SAS. The shape stays the same. Okay, what's next? The corresponding angles are equal. And finally, corresponding side lengths side length ratios are equivalent or proportional, but we were focusing on equivalency. So now you're going to be, make sure you go back in this video if you have any questions or you needed to look up something again, and then you will be completing your daily practice, and hopefully that will reaffirm some of this idea of are shapes similar, are they not similar, things like that. And please reach out to your math teacher if you have any questions. Have a great day, Trojans. Bye-bye.